So now that we've talked a bit about the overview of the LockManager case study, let's start delving into the server structure and functionality. Once again, this is very relevant for your upcoming assignment. So here we're going to focus on the server side, the part that's over here. And we're going to start with the LockManager controller. When we look at the code and we do the code walkthrough, I will also point out how the LockManager application is implemented, because that has some cool features using virtual threads. But right now, let's focus on the LockManager controller. So as you can see here, it's a REST controller. That's the same way we do it every single time so far. We are going to auto-wire the LockManager service, so it'll automatically be created and injected into the implementation by Spring's dependency injection framework. And then we've got a whole bunch of methods that are defined on the controller. And these methods, as usual, are simply going to forward to the corresponding methods in the LockManager service, after first taking things from HTTP format and turning them into Java format. That's what the controller does, among other stuff. Now, one thing to notice here is that the types returned from all these methods are now reactive types. So unlike before with the Spring Web MVC version, where we returned a Boolean or a lock or a list of locks and so on, now we're returning reactive types like monos and fluxes. And you can see in most cases we're returning a mono, but one case we return a flux because we're going to get a bunch of permits, not just one. You can also see how we use the various annotations here to indicate post and get operations. And depending on your point of view, I guess all these things could nominally be posts, because there is modification taking place to some extent, but I just did this to show off post and get mappings. They're easy enough to change once you've got the hang of doing annotation-based type definitions and endpoint mappings. These, of course, are the names that we give, so that's what's going to correspond to the HTTP requests that are sent from the client. And of course, when we do the client side of this, coming up in an upcoming video shortly, we'll have to make sure we have the same names, which is yet another reason why you want to try to use symbolic constants for this rather than hard coding the names themselves, because if you make changes, then you have to have more things modified, whereas this is fairly straightforward to modify because it's all centralized in one place. And then we also use some annotations to indicate the parameters. And these are very similar to what we've seen before, in the sense that we're passing over a request body that's an integer or a lock or a list of locks and so on. And so for the things, for example, that are post requests, we're going to send them in the body of the post request, just because why not? So you'll see later when we take a look at the client side and the HTTP interface client proxy, that uses the same annotation names that we have on the controller, which is another nice thing about the Spring version versus the retrofit version, which had a different set of mappings that were somewhat confusing. So let's talk a bit about the LockManager service. So as you can see here, this is a service, like always, so it can be used in terms of auto detection and wiring of things. And we're going to define ourselves a local variable called mAvailableLocks, which is an array blocking queue. And we're going to do this, so we're going to have as many items in the array blocking queue as we have permits available with this semaphore, with this LockManager. And we'll see how that works out. It's actually quite cool. There are then a whole slew of methods here that essentially mirror the controller logic as usual. And they're going to pass in pure Java types. We're not dealing with request body annotations and post mapping and get mapping annotations. This is just good old Java code. And under the hood, as we'll see when we walk through the next part of the lesson on implementing the server components, that they use this array blocking queue that we looked at here in conjunction with reactive programming in order to implement the asynchronous distributed semaphore semantics, which is super duper cool and shows off some really neat features of reactive programming to make the whole thing asynchronous. So that's the overview of the server-side structure and functionality. At some level, it's very similar to things we looked at before. The overall structure is quite similar to what we had with the Spring Web MVC version. The difference now, of course, is that we're using reactive types to pass data back and forth between the client and the server, and of course, reactive programming in order to do the implementation, as we will see next.